Cool. So I'll start off by giving some context. Hey everyone, my name is Martin. I think most of you know me. And the reason I'm doing this talk, I actually wanted to do another talk, which was something that I've been more interested about in the last few months, which is around Zen philosophy and programming, but we'll leave that for next year. And the reason I'm doing this talk is, well, about a month ago, Darren, hi Darren, wait for everyone. Darren approached me and he said, hey Martin, I know that you had previously done some architecture training in your previous company before you joined, and I know you were an architect, so how about you do that course at MYB? And we sort of said, well, one of the things we want to do for that course is, it's running in Jan, starting on the 19th of Jan. And one of the things that we wanted to do was to have this session so that we just gather some interest around that and give people a bit of a taste how that course would run. What's really important about how we want to run that course is that it is about not one facilitator standing in front of the class and telling everyone all of the wisdom of theory. It's more an interactive conversation and everyone bringing a bit of their experience along, and then everyone learning a bit out of that as we go along. So a few of the people in the room has attended that course before. I think Fazana and Mark. I'm not sure if Dan. No. So you can also. And this is one of the sort of like a subset of some of the content that is covered in that course. So what I mean by subset is really just getting into the importance of architecture today, and hopefully we'll have a bit of a conversation as we go along, given that that's how we want to run the course as well. So the one caution is that we probably have an hour and a half of content, and we have an hour. So we'll have to see how the conversations go as well. All right. So what I will cover today is just first of all why software is hard, because it's not easy. But we'll get into a deeper conversation around that. We'll get into why architecture is important, what software architecture is really, and why should we apply some rigor around doing it. I'm glad to have gotten the real English spelling of rigor. I occasionally made the American one. So if you have any other questions as we go along, by all means, just let me know. So first of all, I'll start with one of my favorite tweets of all time. It's 5 years old already. And it was by Jeff Atwood, who was one of the founders of Stack Exchange. And he was speaking at a conference, and Ordev, and he sort of said there, well, all this process stuff at Ordev is boring. It happened to be one of the big talks that Uncle Bob did, which made him really get next level famous. At Stack Exchange, we have one process, and that is kicking ass and chewing gum, and we're all out of gum. So that's a Duke Nukem reference, which is first kudos, and second kudos is individuals and interactions over processes and tools. So whatever we talk about here today, just remember that we're grounding the conversation in individuals and interactions over processes and tools, kicking ass and chewing gum. So let's get to where architecture comes from, this garden shed, right? So we would say that this garden shed has an architecture.
Sure.
Sure? Yeah? Anyone say it doesn't?
Someone thought it through and went, yeah, I'll do it like so. I
Yeah.
have some experience and I know this will hold up.
Absolutely. So it's got a design, it's got an architecture, but it may not be as intentional as a bigger building. It may not be earthquake proof, it may not withstand certain storms or anything like that. So it's got a certain level of engineering. But for the person that built it, it is fit for purpose. Conversely, to the Petronas Towers, it is a different level of engineering went into those, right? Where, I watched this one documentary where, when Discovery was doing all of these documentaries, and the one thing that they sort of said there is they had an engineering team just to design the cement for the foundations. So that's pretty hardcore. Here it's some dude buys a bunch of stuff. Here it is teams of designers, let alone the people building it. Now, software is actually a lot harder than building buildings. And building buildings is not easy. I've built a house. I know it's really fucking hard. Who's built a house here? Yeah, it sucks. I would never ever do it again, but I definitely recommend it to everyone. So software is pretty hard, and for us to understand how hard it really is, I want to go back to 1987. But before we do that, why is software hard to you guys? Like, what makes software so hard? Pardon?
The variety of ways to implement.
Variety of ways to implement. So there's more than one way to solve the problem. People makes it difficult because people are all mushy and stuff.
The first full, complete definition of what you actually need to produce is the software when you've written it and it's signed off. Because any complete definition of it up until that point has got lots of ambiguity and gaps in it.
Awesome. So only up until we've solved the problem do we actually know what the solution is, which is quite a nice way of saying it. There's a tweet in that. Can't tweet in front of everyone. Anything else?
Accidental complexity.
All right. So accidental complexity. So what is accidental complexity?
You think it's a molehill and it turns out to be a mountain to implement. Or
Okay.
feature creep, or unexpected difficulties just unexpected difficulties solving a problem.
Okay. So these are sort of like abstract problems, and we use our tools to solve them. And that's actually a pretty good answer. So who here has heard of accidental complexity as a concept? Essential complexity as well? So who's heard of a silver bullet? No silver bullet? Like, you must have heard that before, right? There's no silver bullet. There's no... Okay, that actually comes from a paper that was written by a guy called Frederick P. Brooks in 1986. It was published in Computer Magazine in 1987. Give you an idea of who he was. He was a famous architect, engineer, and manager, and he actually ran the OS360 team at IBM. You may know him from Mythical Man Month, and the one thing that people always quote of him is that 9 women can't deliver 1 baby in a month. And that's how software works as well, right? That's the one thing that people always quote him on. The thing that is probably the most profound in what he's done was this paper around No Silver Bullet, which is around why software is actually really, really hard. And the first thing he speaks about is essential complexity. And that is that we solve difficult problems in software, the business problems that we solve. And the reason they're difficult is because they're complex. Like, businesses are complex in their own right. And the solutions don't really conform to the laws of physics. Like, you can't look at the load-bearing capacity or anything like that, right? So they actually conform to the laws of physics. There's one law of physics that it sort of like conforms to, and that is entropy. I'll talk to you a bit about that later. The other thing is that it's changeable. So, as someone said, it's sort of like the solution actually keeps on changing until the point that we go live, and then it still changes. So if we were building a building, that would like going and ripping out foundations and hoping that the building still stands up, right? And then finally, the solutions is invisible. Like, you can walk up to a car, you can walk up to a building, you can kick it, you know, so like the wheel still stays on. You can't really do that with software. So that's the essential complexity, which is one thing that makes software really hard. The other thing is accidental complexity, and that is that we use complicated tools to solve these problems. We use programming languages, we use hardware, we have limited to hardware limitations. We're limited from where we can deploy it, and we're limited by debugging. And these things improve over time, but they're still really hard, right? Because code is hard. So if we were looking at simplifying these accidents, remember this paper was written in 1986. The accidental complexity then was different to what it is today. So object-oriented languages just started becoming a thing. Back then, people still went over C++. The concept of high-level languages started becoming a thing, like COBOL and stuff like that. Well, it was a thing being used more and more in business. They believed that AI and expert systems will have big advances. Graphical or automatic programming, like those designers, those were also like things that they thought will improve over time. Some of the things that did improve was around program verification. So we have tools looking at static code analysis. We have techniques like test-driven development. We have much improved workstations. We have supercomputers in our pockets, let alone the things that's on our desks. And the processing capacity that we have in the cloud is astonishing. And then obviously we have IDEs, and we have increasingly better and better libraries. So we're always making advances in accidental complexity. The thing that what it allows us to do is it allows us to solve bigger and bigger problems as we're going along. And that's where essential complexity comes into play, is where the essential complexity that we have to deal with becomes harder and harder and harder, right? So what is the best way to get rid of essential complexity? Stop solving the problem. So if you had a KPI on the essential complexity, then that would be a good way to meet the KPI. That's why KPIs are bad. But seriously, like, the best way is buy versus build, right? Office for me is the best example. If each of us had to go and implement our own version of Office, I once did a sum like on how many man hours went into Office, and it came around 300 million US dollars up until the point of roughly around 2004 was spent developing Office. That's a lot of money. We don't have that money available to creating a word processor today. So we can leverage all of that work and pay $100 for a piece of software, which is amazing. But now, let's say we can't do that. We actually have to go and solve the problems ourselves. What are the two things that's left? In 1986, Fred Brooks, who is known as writing the best project management book, emphasis project management book on software development, said that the best way to build great software is to grow the software iteratively, incrementally. Huh, that's interesting. So Agile isn't new. In fact, if you go back to the 1960s, you'll see that's the way that people worked back then. The other thing that he said is that we need great people. We need great designers, because great designers create great software. So we grow software iteratively and incrementally, and that's always one part of the other problem. But the other part of the problem is actually we need to have great designs. And that really gets into what we try to sort out with the software architecture part of the equation. So what happens if we don't do software architecture? Why is it important? So let's have a bit of a discussion amongst ourselves. Bit of an awkward room, so I'll suggest that some of you turn backwards, some of you turn to your side, and just have a bit of a conversation about that for a few minutes. So sometimes this works, sometimes it doesn't. It depends if someone picks up. Okay. It's a thing they do at conferences to get people to stop. Sometimes it works, sometimes it doesn't. It helps a lot as more than clearing your throat, which could end up blowing the sound system. So why is it important?
Gives you direction.
Gives you direction. And why would that be important?
At least know where your scope or where you're going and what you're planning to build.
Okay. Okay, so it gives us direction.
Stops you drifting from the original goal in the project.
Stops you drifting. What happens if you don't have the direction and you end up drifting?
Lots of
Every developer in the team goes their own way, does their own thing. So
Okay.
But that sounds like coordination. That sounds like cooperation.
Yep.
So
Yeah.
that might be. I think it's more to architecture than that. We can.
That's an element of it, absolutely.
Yeah.
Be some of the other things that go wrong if we don't have software architecture.
There won't be any cohesiveness in the product as a whole.
Yeah.
And teams will build up their own different things.
Yeah.
But not necessarily they'll stick together.
Cohesion is one of my favorite words.
you end up solving much more complicated problems than you actually need to.
Over engineering, potentially. Yeah.
The time in which we deliver values could slow down. We won't be able to add value as quick.
Yeah, maybe solve more problems than what we need to, and then we end up delivering slower. We potentially create messes because everyone's going in their own direction, and it becomes harder to deal with the messes. What are some of the other reasons?
It's hard to grow the software if we don't have a architecture that can be evolved upfront. That's easy to evolve.
Okay, so we make some decisions about evolutionary design up front, which allows us to be faster in the future.
I think there's one other aspect of it as well. It also creates the points for you to handle change. Don't know what change is going to be.
Okay.
It's going to happen at some point.
There's actually, it reminds me of a really, really good talk that Kent Beck did, and maybe worthwhile touching on that a bit later. So will you remind me about that? Yeah. Awesome. I feel disappointed because there should have been a whole slide section dedicated to just that. So some anti-patterns emerge, right? Some of those anti-patterns could be sort of like House of Cards, where we didn't really think about how things interconnect, and therefore it becomes brittle. We may have a lot of synchronous calls. We may have a lot of layers. We may have indirection where we don't need it. And there's sort of like this House of Cards sort of like thing that happens. Or it becomes this sort of like shantytown. There's no recognizable structure. We don't really know when the system starts or ends. This is also called big ball of mud. This sort of like happens when we didn't really think, we just keep on building. And we think locally, this is what I'm doing within my story at the moment, or this is what I'm doing within the milestone that I'm working on at the moment. And we don't really take a step out and look at all the other things that's happening around us. So usually as a consequence of a lot of tactical decisions. The next is spaghetti systems. Who's dealt with spaghetti before? That's sort of sucky because you sort of like go on a debugging thread and you like build breakpoint after breakpoint after breakpoint for days and days and days, and eventually get to the point and then you lose the breakpoint. That's roughly how you know you're dealing with spaghetti. This usually happens again where you may have just too deep layers of dependencies. You may have introduced way too much complexity. Good sign to know that you're doing this is looking at the number of references that a project has. And the next one is this sort of like a stovepipe architecture. And this goes again back to sort of like a whole bunch of tactical decisions where things are sort of like patched together as we're going along. A better image is like looking at some of the sort of like favelas or something. You see like the sky with all the sort of like TV dishes, and it's just this mess of TV dishes because I've all just been smacked on. And it's again people making decisions about where the architecture goes, but they never finish executing on that. So they start upgrading to the new version of .NET, or they start implementing a new pattern, and they never fully finish executing on that, and you start becoming this sort of like monster that's like half .NET, half Java, half .NET 2, half .NET 1, some VB, and like and React and Angular. And
in a scenario, they don't think that's a failure of commit. It's a priority thing going, no, don't bother making everything consistent and finished. We've got another thing to do now. So you could say, I don't say it's a failure of architecture. You've got mismatched and bundled up things that are legacy and crap.
Okay.
If someone says it's important to sort it out, great, you get a chance to sort it out, cool.
So
If you don't, is that a failure of architecture?
It's a failure if it was unintentional.
Yeah. So our responsibility is to point out going, you realise this decision means we're about to leave a whole lot of crap.
So now
the architecture doesn't stop, right? It's not something you do up front and then
Yeah.
you get it done. You architect the system on an ongoing basis.
Yeah, spot on. And that's where entropy comes into play. And I would say that the one thing that the activity of architecture is it is the management of quality within the solution, the intentional management of quality. And quality is the level of engineering that we apply to the solution. And a good example for me was if you look at a entry level like VW, which is roughly built with the same engineering practices as the highest end Audi. It's the same company, it's the same chassis. The level of engineering that goes into both of them is the same. The quality of the product has been controlled differently. And that for me is a good image to explain explain the quality. Now, obviously, software systems are invisible. They completely change the whole time, even after the initial production has happened, and that's where entropy starts setting in. And we need to, from an architecture perspective, ensure that that integrity is maintained as the solution goes along, so that entropy doesn't set in, and that one of these other anti-patterns emerge. And that's sort of like the one architecture. These patterns emerge, and they emerge because quality is neglected, and entropy sets in. Does that comfortably with you? I can come up with a different answer if you want. So the other thing is fit for purpose, and I think Dan may have mentioned something around that a bit earlier. Was that if we're not intentional about the quality, then we may unintentionally over-design or gold-plate our solutions. So we may end up adding quality where we don't necessarily need it. And that very often happens, very often manifests in developers making things generic where it shouldn't be, or making it flexible where it shouldn't be, as opposed to focusing on simplicity. And those two facets of quality is sort of like the core around software architecture. Is one is making sure that we engineer at the right level, and the other one is making sure that we maintain that level of engineering as we're going along. Okay. Cool. And entropy is unavoidable. At some stage, the system becomes so unmanageable that it becomes a mess. I've not yet seen a system that has just lived on and on and on and on. Who's anyone here? Other than the Linux kernel? Well, so what is the software architecture thing really? So we know it's got something to do with quality, but how does it help us with quality? Over to you guys. Awesome. I have to tell you this joke. So I once did a talk. I was working at a company where I was an architect, and a consultancy came in, and they had about 70 slides doing a sales pitch, and every slide that architecture just misspelled in a different way. It got to slide 55, and we basically said, okay, we've run out of different variations or spelling errors. I think this meeting is over. Anyway, so thanks. I'll fix that right now while you guys discuss what is architecture. Over to you. See, it works the second time. Did you want to say something?
Is this question about the software architecture as a process or about the structure? Like, this question is what?
As a structure.
As a structure.
As a structure, I guess we'll start getting into as a process, but we'll start off by just defining what is an architecture. Yeah. Okay. So, anyone? The important stuff. Okay. What is the important stuff?
I think things that will be difficult to change in the long term.
Okay, so what are those?
The important stuff.
I think you have a bug.
The foundations your system is built on.
Foundations your system is built on. I like that. Foundations your system is built on. A lot of heads nodding. So
The universe that you're going to build it in.
the universe that you're going to build it in. Okay, sandbox-ish. Yeah. Set of guidelines that you follow to nurture your system. That's a very agile answer, like that. We had very esoteric, we had agile, quite a programming, recursive one. Anyone else?
Yeah, the diagram you draw to show it to management.
That is interesting. So the diagram that you draw to show to management, and I think for me that's part of the reason I'm doing this talk, is to help us understand, well, what is it beyond that, beyond that sort of like potential fear of mistrust. But I'll get into that when we actually talk about the process and some of the benefits out of the process, and we'll just first get around the definitions. Anyone else want to add something at this stage around this stuff?
So
No?
what I'm hearing is a plan. What I I hear
Ah.
software is a plan. So
Yeah.
that's the plan. It's what you show someone about a particular system.
I love that.
Software architecture is about how you get to coming up with a plan, how you maintain and apply and implement.
It's a plan, and activity is how we come up with the plan. That is a pretty cool answer. I like that.
No, I was simply reflecting. What I hear from people's answers was talking about it as if it is a plan.
Yeah.
It's your architecture goal. It's this component talks to that component. I thought architecture is about how you devise that and come up with that.
And there's a good lesson about software architecture in that is by listening to each other and opening ourselves up, we may come up with better definitions of things. So thanks for that.
It's like a continued practice. I mean,
Yeah.
we're writing code every day, we're making decisions that's
Yeah.
going to affect the system every day.
And what are those guidelines? What is that plan that gives us at least some sort of like framework in which we make those decisions? So I love systems thinking because it's such a versatile concept. So systems thinking is this idea that everything is a system. That makes it awesome. So I'm a system as a biological system, and you're all biological systems, and your team is a system, and my laptop is a system, and my car is a system. And all of these respective systems, if you look at their building blocks, like my car's wheels, its chassis, its engine, those respective building blocks are actually meaningless until they're put together and they work in cooperation. So we're talking a lot about the boundaries of the system, the components inside the system's purpose, and their interactions. That's systems thinking, right? Which is interesting. Also referred to as systems theory. The interesting thing with what Saria said a bit earlier around cohesion and coupling is the two sort of like dominant concepts that drives good systems thinking is around cohesion and coupling. From managing a system, we also need to look more at the interactions as opposed to the components. But park that because that will become not the focus of this talk. So a more official definition out of the IEEE would be the fundamental organization of a system embodied in its components, the relationships to each other, and the environment and principles governing its design and evolution. That's roughly what everyone said, isn't it? Sort of. We don't have the plan bit in there. But we talk about all of these components, how they interact, and some of the design decisions that's governing the evolution of the system. So the evolution of the system, so it's also not a static thing as well. Or as Ashik said, it's the important stuff. The critical, I just use better language for fancier language, but it embodies the critical design decisions. So why should we then apply all this rigor? Right, now that we know what the architecture is, it's basically bringing structure to how these things interact with each other. Why should we apply rigor? And again, have a bit of a conversation around that amongst yourselves. Cool. I just sort of like waited for the conversation to start die down. So why should we apply rigor?
Otherwise, it doesn't make any sense to have architecture in the first place, right?
Sorry?
Otherwise, it doesn't make any sense to have architecture in the first place, right?
Otherwise, it doesn't make sense
If you
to.
don't follow it, why would you have it?
Okay.
So the benefits of the architecture, you don't get the benefits if you don't apply rigor.
Okay, so we should be serious about our approach and make sure that when we consider these things that they actually get implemented. Absolutely. Anything else?
I think you open yourself to defects, right? You're allowing those quality issues to
Yep.
just saying the application itself may not be changing, but the environment you operate in is.
Yeah.
If you don't apply rigor, then
Yeah.
you're going to miss stuff.
The architecture is not static, it evolves, and you'll introduce new features or components that don't fit into your current architecture, so you've got to evolve it, assess it, and then communicate it, make sure everyone's understanding how that fits in.
Okay, so there's an element of communication. There's an element of having a look at what some of our decisions were, so that we can look back at some of the decisions that we're trying to make today, and so that we can evolve the system as we go along. I think maybe the question also needed some massaging, and maybe why do we need to be a bit more formal about it as well? So rigor and formal, and that sort of like goes down the path of another typo. I curate my own slide. about individuals and interactions over processes and tools, right? So I'm sort of like starting to talk about that, hey, we need to maybe be a bit more intentional about it. We may need to think a bit more about documentation. We may need to think a bit more about how we communicate about these things. But it should never come at the cost of us working together effectively as people. In fact, it should be done in a way to support us working together effectively as people. And there are two examples that I want to share with you out of my career, which was super enlightening moments. The one was in 2006. I was working at the Johannesburg Stock Exchange, and I was integrating into systems at the London Stock Exchange, and we were part of the comms integration team, so doing the integration between all of the systems. It was about 60 different systems that we were integrating to, and we had come up with like an A3 diagram that had just the high-level system components in the environment and how those things connected to each other. At the same time, it took us about 3 or 4 weeks to really flesh it together, because there was a lot of conversations with people trying to figure it out, and maybe we were not really incentivized to get something out the door because we were paid by the hour. Consulting companies, we worked, so gold plating. And what was interesting was we also created a whole bunch of functional and technical specifications and architecture specifications, and we never even read those documents, right? Let alone someone else. It was hundreds and hundreds of pages of documentation that we never even read. However, that one diagram, I went back there in 2012, and the first thing that they pulled out was the diagram that I created 7 years ago, and they started talking to me about their systems. So you need to use this to help you communicate about the tools, right? About the systems. Another situation I was in 2007. We were working on a system, and we thought, hey, we have an opportunity. I'm always been a bit late, so we have an opportunity to apply the rational unified process and do object-oriented analysis and design. But we'll listen a bit to the Scrum stuff, and we'll do some of that. And inevitably, we ended up creating models after models after models, and the printed out documents of the generated documents from all our models ended up being over 900 pages. We created one document that was a 30-page document and if you take all the corporate crap out of it, it was probably a 20-page document. And that 20-page document was used almost weekly in the team, because it embodied the core design decisions that we made, that we felt was solving the constraints that we were working in the environment, solving the quality things that we were trying to work to, and some of the problems that we've encountered previously. And that was used all the time. So just the trade-off, how 20 pages was infinitely more valuable than 800 or 900 pages. And that for me was a massive learning, because documentation actually doesn't imply understanding. But we need those documents to be able to roll it out on the table. Similarly to when you build a house, which is way more simple than building software. We roll out a plan. We have a look at, if I drill there, I'm going to probably hit a pipe. And if I drill there, I'm probably going to shock myself to death. So I probably need to drill here. And hey, that will be the best place for me to lay my new audio cables, right? And houses are way simpler than software systems. So what is important here is that when we create these documentations, we should consider the concerns of the people that will use it. Typically, when we look at 4C or we look at 4+1, there are 5 primary concerns. How do I describe this to someone? How do I navigate the development environment? How do I navigate the production environment? What are the things, the domain concepts that we're talking about? And what are the sort of like main sort of like business processing scenarios? But that's not as important. Those first 4, development environment, production environment, our domain models, and our how do we describe this, what we've built. Because, hey, that stuff, you should be rolling it out every day, and that's what you should be having a conversation about. I assure you, you won't have as many confusion and misalignment as what you're having today. But it's actually a bit more than that. It also includes some of our key processing scenarios. What does data behave like in our system? What is the constraints under which this thing was designed? We have a situation with a system in a practice online where it was designed to build an online sync solution for something, and ended up being a contact solution, right? So it took us a bit of probing to figure out, hey, this was what it was designed for, and this is what it's being used for. Hey, there's a bit of a disconnect. So what were the design constraints at the time? What are the quality of service requirements? Did we consider security at the time? Did we consider performance at the time? What are the key mechanisms? What are the cross-cutting concerns? What were some of the key design decisions and assumptions? And then finally, what were those 4 models that support our thinking around it? These are very lightweight things that will help you make informed decisions about your solution, because we can't keep everything in our heads. Sometimes as human beings, we need tools to help us remember stuff. So it helps us to manage the complexity from different perspectives, because sometimes I'm looking at the development view and sometimes I'm looking at a production view. It helps us remember why we did things. It's like, oh shit, yes, yes, that's why we did it. Navigate what we've built, so that when a new person joins or we pick up the code that we haven't touched in a while, we can pick something up. It's like, oh yeah, that's over there and this is over here. And it also helps us structure our thinking, right? And I see this happen quite a lot at MYB in meetings. It's like people are having these conversations and I try to build up these models, but you can sort of like see like these models in people's heads, and you can see the different gaps in everyone, and then they keep on falling into these gaps and the conversation just goes in circles. I'm like and very importantly, it allows us to communicate to others. And this is important because, yeah, sure, and I chased him away, talking about the manager. Like managers at MYB and managers hopefully in most organizations also helps the team connect to all of the other teams that's in the organization and helps us bring alignment. And by having this, it allows us to have those conversations. But it also allows you to have those conversations internally. It helps you to make those decisions internally. It helps you onboard new people. It helps you have conversations about changes that you need to make. So there's all of these other reasons that you need to consider. And like in some of the tribes where you have people dependent on you, it is something that you can go to and say, hey, this is how we've done stuff. Or if you accept pull requests. So that communication bit is pretty important. So the last thing is, clearly I didn't do the dry run of this talk last night. It was midnight. So who is the person that does this? Is it the architect? Maybe it's the whole team, yeah. So, damn, now I have to go through my slides. So it's not the architect, right? And maybe architect is not even the right word. Not a foreman, like I know Uncle Bob spoke about the foreman, or master craftsperson, or surgeon, or lead engineer, or anything like that. Those are all bullshit fucking titles, right? At the end of the day, it's about the team. Now, one thing that we do need in environments is people that help us bring alignment, because there's all of these different things that's happening all over the show. And there is a need for us to be aligned with other people. So the reason I have this bazaar on the photo was I, for a long time, misunderstood the difference between cathedral and bazaar software engineering. And I interpreted it as what I'm going to say now. You can go and read up about it, what it actually is. I interpreted it as cathedral is sort of like this top-down approach where an architect dreams up a design and people very fixed structured design that never really evolves over time. And it stands there for years and years and years, and maybe it's not really ever used. Where a bazaar is more emergent, people get together, they work together to solve their problems. It's a bit more chaotic, it's a lot more vibrant. But even in this place, there's someone that's making sure that there's some level of cohesive structure to make sure that people can actually walk and get from one place to another. So the role of the architect and maybe even the dev manager at MYB is to also help us bring that alignment to the rest of the organization while the teams focus on what they're doing individually. But ultimately it lies with the teams. The teams is the place where the decisions are made, because you have the most information on a day-to-day basis. So I've covered a couple of concepts about why it's hard, why it's important, what it is, and why we need some process around it. But at the end of the day, we really need it because it also helps us to understand what is needed to create great systems, because great designers create great systems. And that's it. I think this is an awesome opportunity for you guys to start looking at how you can be more intentional about design within your systems and get that visibility out. So thank you very much. Any questions?
So what's your preference on one side having one architect who makes decisions, or one having the team who makes decisions? What's from your experience works better?
So what almost always works better is the architect working with the team to help them make the decisions, to make the team aware of the design constraints within the larger organizations and the dependencies within the larger organization, and help them get to the conclusion themselves. But the ultimate decision should be with the team. Remember that the team works on a service or a component right here, and it is a part of a bigger ecosystem. So to get that alignment to the bigger ecosystem, the dev manager, the product manager, and the architect works with the team to help bring that sort of alignment. So given that at MYB we have some very technical dev managers, and in those places we have less architects, in some places we don't have very technical dev managers, and there we have more architects. So it's about bringing alignment and helping you just think about what you're doing from the outside in. So sort of like seeing the forest from the trees. Does that answer?
Kind of.
So the team. The short answer is the team,
Okay.
with help.
Should architecture be applied to no matter how big the system is? What happens if it's a really small system with one team as opposed
Okay.
to multi-team?
Awesome question. Every single system that you will ever write has an architecture. So fit-for-purpose engineering is asking yourself, what level of rigor do I need? All systems have an architecture. So sometimes your architecture is, hey, this is a small system, I want to get it out of the door quickly. I'm going to build it in Rails or Django because, hey, that will allow me to get shit done quickly. So that is my architecture.
Following my previous question, don't you think that when you have a team making decisions, you might end up having some compromises, which are not really making architecture better, but just making team to make this decision?
It's a phenomenal question, and I was hoping that would come up. So you're talking about self-organization, and I think a common misconception about self-organization is that it's decision by consensus. Self-organization isn't about consensus, it's about trust. So it's a team entrusting one person to make some of those decisions on their behalf, and then giving the team visibility on what those decisions were. So that's self-organization. If you don't have, if you end up having too much consensus the whole time in teams, you're never going to end up making a decision because people are going to end up compromising the whole time. So for me, it's about trust, less than it is about consensus and democracy. Okay. Yeah. Okay. I saw Mark giving me a glare there. Did I break an agile law? It's like, whoa, I can't hide behind the camera. Okay, cool. Okay, agile gods saved me. But seriously, I think like, you know who the people are in your team. You know who you trust to make decisions. You know the team trusts to make some of these decisions. And sometimes someone is just going to go off and have to get some of the stuff done. Yeah, but you all own it together.
I just like to add that in these decisions, it's always important to have the conversations about the trade-offs every decision has, and how is that going to benefit you or impede your ability to grow and improve over time.
Yeah.
I think that's important.
And part of that is like, part of what gets us to build software quicker is not to deliberate and come up with the best answer up front, but to make a decision, start building and learning from that, and then changing what we've done. Making a decision, taking it to the team and realizing, oh shit, we need to change this, this and that. And that for me is a sign of a team that's going to build software rapidly, because we're not afraid to make those decisions, and we rather use those decisions to give us feedback so that we can change them decisions later on. Yeah. Cool. Awesome. 10 minutes left, which means I have 10 minutes for lunch. By all means, come and have more questions afterwards.
Thank